my presentation will be a little bit different. Rob there is a bit in touch on some of the points. What I would like to talk is a little formal system modeling global level, and also something that is leading the literature recently focusing on looking at global problems through the nexus between the food, energy, water in this particular case. Conclusions of the presentation, because I'm standing in front of you at lunch. Some of you who missed the rest of the presentation. The food, energy, nexus emphasizes the links between these three subsystems or systems. And the concept has been introduced in the literature as an attempt to overcome the kind of single sector view and single sector approach. Lots of applications since 2010 were devoted to this particular. I did a review in preparing this presentation, and the paper on which this is based on over 300 papers that are carrying the title the Nexus concept of the application. What I have tried to do here is, as Rob pointed out, to say that structure matters. Structure of the model is essential. And the dynamics of the performance are related to the feedbacks, which are basically elements of the structure together with the delays. So what I have done, I tried to look at the global model, for which luckily I had some work done before, and then reduce this model to the concept of food, energy, and water, basically reduce the structure, disconnect number of feedbacks, and simulate basically both versions and see the difference in performance, and see the difference in dynamics. And the final conclusion is very, very strong, that Nexus approach is basically misleading the decisions, because that interaction, which is being cut by eliminating number of sectors and cutting the feedbacks, is eliminating the essential processes which are involved in the dynamics of the goal. I'll talk a little bit about the models and the modeling, about the simulation experiments, give you the walk through some of the results just to convey the main message. For this book, I'm finding out, with more presentations at different occasions, that we do use the same language, but we don't move the same thing. So I think the limitations are important. And these are the kind of key three words of that we use in Nexus, that defined as a connection series of linking two or more things. Food and water is interaction between these three different systems. And the system is defined as a collection of elements and components that are organized and working together towards the goal, particular goal. I'm not sure how much I need to provide as introduction of the global change for this group. Basically, what we are talking about when we are talking about global change, we talk about population growth, and I'm adding migrations, which are probably today much more important in this particular area. Land use change, climate change, and their impacts on infrastructure, but much broader seen infrastructure, not only the physical, also the soft infrastructure, including institutions, societies, how societies reacting to these changing conditions, even some cultural modifications and adaptations to changing conditions. The outcome of that is nothing else than by basically increasing the complexity and uncertainty of the problems that we're dealing with. And this is where I think systems approach definitely has some advantages. In early 50s, modeling of global change, or the research in the area of global change, was starting from the basic kind of assumption that the Earth is a closed system in which natural resources and environment determine the boundaries of population growth and economic development. And since 1950s, a number of larger scale models, there is a work from United States, you may, you are too young to remember, born at that time, the work of Meadows and others, we're talking about the limits to growth, published, lots of interesting outcomes of that work. From 2010, I'm seeing actually that this kind of same work is now kind of deviating much more to the Nexus approach, where food are taking very significant role because of the seriousness and the links to the global changing conditions I mentioned in the previous slide. Implementation of this identifying the quantifying the connections between these three sectors, modeling these three sectors and their connections, and then simulating management scenarios for kind of decision-making assistance. I mentioned that over 300 pages were reviewed this slide earlier. Kind of agree that this work did not really end up in producing something appropriate as a toolkit that you can kind of take and implement in different areas. Nor that this particular approach by using global problems to the Nexus concept or applying the Nexus problem, validating the claims that this approach is including the results of and governments. That's, I think, the conclusion that comes out of this paper. But the papers are still coming out. Yes, they are true. Because on the first one, review this year. So it seems that simply the way of thinking is continuing, and application, unfortunately, today you can publish everything. Is really pointing and continuing along the same line, and ignoring the fact that there is a very strong, I think, a very strong message in understanding the systems approach, understanding the importance of the structure, and applying this kind of thinking in the context of answering the questions, understanding the globally changing conditions, understanding the impacts. So I stated as a kind of research question here, how appropriate is this Nexus approach to using his, its limited representation sectoral feedbacks that relate these three variables, and what is the utility of this particular approach in looking at global problems? Assumptions that are kind of made here is that the global change problem are or require systems approach, and I think the whole conference is devoted actually to that particular or supporting this assumption. And then in this work, in order to kind of make my argument, I use a system dynamic simulation, which is one possible technique for tuning important complex systems. This is the starting point. Roland, I think, presented one equation which is part of this particular model, together with 469 other equations. So, in summary, we developed, my research group developed over a number of years, a global model that is looking for this equation of different sectors, very strong interactions between the key variables that are determining the global change. So you see that we incorporate environment, incorporate the carbon cycle of population, a number of sectors dealing with water demand, for economic cycle, and so on, energy, economy, population, land use, food production, and what we see is a very high level of interaction with different colors are pointing out the key feedbacks between these different sectors. And each of the sectors has its own a detailed structure. We try to count on the number of feedbacks covered by the model, and it's somewhere between 8,000 and 9,000 feedbacks running the dynamics of this particular model. So now, what I'm not sure how you can see. So the shaded area of the previous graph is basically extracting what Nexus is doing. Is actually looking only the sectors, the shaded area, and disconnecting at the high confidence level all the feedbacks that exist in the sectors in the shaded area and the sectors outside. That's the kind of the idea behind the approach we implemented in this work. As you can see, 5 different subsectors of the large model are now fully representing the food, energy, and water. And what we have done by disconnecting the feedbacks, we needed to replace the inputs which are essential for functioning of these 3 different subsystems. So this is being done now exogenously by providing the inputs into this revised model. And by you can see here, for example, how these connections are working in the climate model. We are bringing the global temperature change exogenously into the model, and then it has the consequences of the model, because we do not have the link between the climate and, let's say, water or energy or the 5 sectors and this is all kind of done, treated, integrated into modified model of the global one, and then the simulation was done with both of them in order to do the kind of comparison in the performance. So basically 2 experiments. One was the original large-scale global model as a baseline, and then the second experiment is running the reduced model and comparing the results with the baseline. I'll quickly walk you through the results. So just to show the assumption, the structure is essential, and then you modify the structure, you eliminate your number of feedbacks. It's definitely visible in the results. 2 lines are showing the results of global, also the full-scale model, and dashed lines are showing the results of the modified or the Nexus-based model. Here you see the difference in the simulated temperature, which is obviously pointing out that the Nexus model is very much underestimating. I forgot to mention that the simulation scale is very common, 100 years, what the climate models and other global models are doing. And you see the huge difference in the just towards 100. If you look at the economic, the capital, which is coming from the economic sector, of the agricultural global model, and it's showing the continuous kind of growth of the economy, where the next phase modification of the model is, completely demonstrating different stuff, different type of dynamics, because of the lack of interaction between the economic sector and the remaining sectors like climate, water, land use, food, and so on. So population-wise, the same thing, except that what you can see here is a different kind of direction. The Nexus model is predicting extremely big exponential population growth, because there is no, because there is no interaction between food and other sectors that are affecting the population growth. Migrations, and what our model, the full-scale model, is showing exactly like closer to reality. some of the predictions of the United Nations right now are actually showing a pretty significant decline in the population growth compared to, the population and population growth is a key factor affecting the future. These are the key coming slides are the key variables which are basically so the Nexus quantity. So certain availability of a certain software, and you can see that the Nexus growth is under any available water really significantly. If you look at the difference was depending on is 30-40%. If you look at the agricultural water, which is also part of the water, is the dynamics are a little bit different, but again, at the end, all the efficiency next concept. The energy production, the third component of the Nexus is also to show that installations very significant increases. So I can go into details of every of these particular slides, but I think you're getting the key message that by disconnecting, by implementing the concept of the Nexus, which is only looking at some of the subsystems of the global system, is really limiting approach for future implementation or policy making and so on. That's the graph that shows the food production. Food production is very much related to the population growth and migration, and that's what the global model is capturing, and Nexus is out of the image. So coming back to my conclusions, because you survived. This particular research is emphasized the links between the kind of food, energy, water resources systems. The approach is introduced, in an attempt to reduce or eliminate the single sector approach. Methodology that's used in this particular work compare the global model and revised model to mimic the Nexus approach, and the results strongly showing and suggesting that Nexus approach is really misleading the decisions, and its application should not be used. The interesting point is that in spite of the 300 papers we do this particular work, we didn't find any paper that was talking about its application. So it seems that either the approach or the results are not being attractive to those who make these decisions, or they realize that there are some limitations in the message that's produced from this type of model. I'm not sure how many of you are interested in this, but every work that I do is purely public. So there are all models, large scale as well as modified model. And all the data we use in the simulation are available. They are on the Zenodo archive platform. You can easily access them. There are a number of papers that are published on any model, the global model. And if you have interest, my website contains all the publications and all the information. And I'm easily reachable at Simonovic at uw.ca. Thank you very much.